โอเคนะครับก็ขอสวัสดีทุกท่านนะครับผมเทียนเอกท่องเอกการค้านะครับ Business Development Manager นะครับวันนี้ขอรับหน้าที่เป็นพิธีกรนะครับเราเข้าสู่วันที่2ของ Webinar Series นะครับในเมื่อวานนี้เราพูดถึง EdgeCore ไปแล้วนะครับซึ่งจะเป็นฝั่ง Hardware Vendor ในคอนเซปต์ของ Open Networking นะครับที่สามารถแยกฮาร์ดแวร์แล้วก็ OS ซอฟต์แวร์ออกจากกันได้เพื่อยุคอนาคตที่เราจะมีเรื่อง cost effective มากขึ้นหรือว่ามีเรื่อง automation ที่มากขึ้นตามมานะครับสำหรับวันนี้เราจะเป็นหัวข้อที่ชื่อว่า Cumulus Open Networking Software for the Modern Data Center นะครับเพราะวันนี้จะพาทุกท่านมารู้จักกับในฝั่ง OS บ้าง Cumulus ก็จะเป็นหนึ่งใน OS ของคอนเซปต์ Open Networking ที่เป็นผู้นำในตลาดอยู่ในปัจจุบันนะครับก็มาดูกันว่าสำหรับ Cumulus แล้วในเชิงของ Automation เองในเชิงของ Cost Effective เองจะทำได้อย่างไรบ้างแล้วก็ตอบโจทย์ในตลาดได้ขนาดไหนนะครับก็เรามาสู่วันที่2นะครับก็จะเป็นเรื่องของ OS นะครับแล้วก็พรุ่งนี้เราจะมีอีกวันหนึ่งนะครับในเวลาเดียวกันบ่าย 2 โมงนะครับก็จะเป็นพาร์ทของ SDN Solution นะครับจะเป็น Abstra นะครับเพื่อไม่ให้เป็นการเสียเวลานะครับผมก็วันนี้เราได้รับเกียรติจาก Cumulus นะครับมีเจ้าหน้าที่ฝั่งเทคนิคอลนะครับคุณเอ็ดดี้ทานนะครับจาก Cumulus เพื่อที่จะมาให้ความรู้แล้วก็แนะนำโซลูชันของ Cumulus ให้กับเรานะครับคุณเอ็ดดี้ทานจากสิงคโปร์นะครับยังไงส่งต่อให้คุณเอ็ดดี้นะครับ so please welcome Mr. Eddie Tan from Cumulus.
Hello everyone. Okay, my name is Eddie, right? So I'm actually the regional SE for Cumulus Network, right, covering Asia. So on behalf of the EasyNetwork today, I'd like to very welcome you guys, all right, during this very interesting time, all right, for this event. Okay, so I'm not sure whether you guys have heard about what Cumulus Network is. So I have actually 2 slides in this webinar, all right, 2 different sets of presentation. So the first set that I'm going to go through is actually on a brief intro of what Cumulus is doing, all that, okay, and then the other one will be more focused on how you can actually use Cumulus, all right, in the campus environment. Okay, so I'm not sure whether this is the first time you guys have heard about Cumulus, okay, but Cumulus is kind of interesting. We started up this company about in 2010, exactly like 10 years ago. So 10 years ago, we think that there's a lot of like proprietary kind of net OS out there, all right, and you know, you always have to buy the hardware in order to actually do the software kind of things. So in a way, you are kind of being locked down by vendors, all right? So for instance, like Cisco, Arista, Juniper, to name a few. So to use some of those features, you got to actually buy their hardware, and then you also need to actually buy the software, and the software basically comes with different types of licenses. All right, then you have to actually, you know, go through a series of exercises to actually get the correct version of the software, you know, to do what you want. And sometimes you can get a version of the software that do maybe only 10% of it does what you want, and maybe 90% is not what you want. But in the end, you still have to buy the software, all right, and live with it. Okay, the other thing is with all these so-called vendor lock-in, all that, right? And all these guys basically has this end of life cycle, because a lot of times if you look at end of life of a device, it's kind of ties on with the hardware more than the software, because software usually can last longer than the hardware. So from the hardware perspective, if let's say maybe Cisco say that 2 years later, 3 years later, this hardware end of life, so it means that you no longer have the kind of support that you want, right? So then you have no choice in this case. So Cisco says that they now get this, all right, this is a new one. So you still have to get a new device, all right, maybe learn something new and then get new license, and the cycle goes on and on. So it's kind of like hard to manage, right? It's kind of getting out of hand. And as you can see in today's world, things is actually rapidly, all right, provisioning. In other words, rapid provisioning, things is getting very big. All right, so are you going to actually be able to do all these, or be able to sustain all these implementation, all right, in a very scalable way or in a very cost-effective way? So that's why in 2010, Cumulus basically emerged, all right? So, and together with Cumulus, there's also this term in the industry, what we call open networking. So to actually understand Cumulus, you also have to understand a little bit about open networking, because open networking basically means that we don't want to tie to anyone, any hardware, meaning that the software can run by itself, all right? The hardware can be anyone, not necessarily has to be Cisco or whatever. It can you choose what hardware you want, and then you just load in the software. So the concept is pretty much like the server kind of concept, right? You buy your own hardware, all right, for the server, then you load the OS. So open networking basically targets that. In other words, using a switch, all right, what we call, sometimes we call white box switch, all right? The layman term is what we call white box switch. So for the white box switch, you can buy it from whatever vendor, all right, that actually implements that, and then you get an open network OS that can load on it. So that way you can actually change the hardware anytime you want, and you can actually still keep the software, you know, for as long as you can. So that's what, in a nutshell, what Cumulus is doing. And of course, to support that, Cumulus basically come up with this thing called Cumulus Linux. So Cumulus Linux basically runs on top of all these boxes. As you know, Linux is actually kind of open, all right? It's a kind of open OS. So because of Linux, you can actually run on a lot of platforms, right, out there. Any kind of platforms that can actually support Linux, and they can support open networking, or what we call ORing, then you can actually run Cumulus. So in a nutshell, this is basically what Cumulus is. All right, so this is what we do. Linux networking. So our network OS is actually a Linux. All right, so the Linux is actually not a modified Linux. All right, so it's actually any kind of Linux that you know. Okay, except that on top of it, we actually add in some of the networking features on it. Okay, so the other thing to highlight is that because now we actually use Linux as for networking, it also means that in terms of automation, it becomes very simple. All right. I'm not sure whether you guys have heard of automation, because automation today is very, very popular, all right, very, very crucial. In other words, means that instead of having like many engineers, you know, going down site to actually implement this for about a month or so, or maybe half a year, you know, just to get things going, you probably can actually do this what we call zero-day provisioning, meaning like within a few hours, you can provision something very huge. Okay, so just some of the stuffs, all that. So basically, we are actually everywhere. Okay, but today the team that I'm going to present to you guys is more on campus. Okay, but predominantly what we are doing for Cumulus, we are pretty much like a data center. All right, we are a data center kind of a provider. In other words, we actually our Linux, right? Our Cumulus Linux is actually more for data center kind of setup. Okay, so most of the important things that you have, right, then you need to have all that. For instance, like you know, EVPN, VXLAN, you know, BGP, OSPF, and some of these that you've seen here in this slide, like some of things like DACAS, you know, Radius, VLAN, you know, MLAG, OSPF, all that. So we actually support all these. Okay, so in other words, today we are actually kind of like enterprise grade not even enterprise grade. We actually, beyond enterprise grade, we actually also more on system, on service provider grade. Okay, so our customers basically is very huge. Okay, in other words, actually beyond the enterprise. Okay, we have like for instance in Japan, all right, some of our customer, the slides that you've seen here is pretty much general, all right, that we have like globally, all right. So, but pertaining more in Asia, we have folks like in Japan, we have this Line. You know, I'm not sure you guys heard of Line. Okay, Line is actually something like equivalent to WhatsApp. You know, so they're actually one of our biggest customers. I think they have like thousands of switches. Okay, we also have like Yahoo Japan. You know, Yahoo Japan is also very huge. So we are talking about like our customers when they actually use Cumulus Linux. It's actually even beyond your imagination. It's more what we call something like web scale. In other words, you can say that easily a few hundred switches. All right, few hundred switches, few thousand switches, tens of thousands of switches. So they are in the likes of what Google, Facebook, Amazon is doing. Okay, so and you see that because they are using Cumulus, that's why they can actually scale very fast. Right? Because Cumulus is actually really meant for something that's very scalable. It's really meant for what we call hyperscale or web scale kind of implementation. So the slide that you've seen here is just some our customers globally. Okay, this is not all right, just some of them. We have a whole list. Like recently we closed in US, we closed a few big deals. One is actually Apple. Okay, so Apple basically is using Cumulus Linux. All right, then we have Visa and Amex, American Express. These are some of the latest ones. But earlier we have like folks like Chase. Okay, have Medallion. Verizon is not listed here, but Verizon is actually a service provider. So Verizon is also using ours. And of course in Asia, one of our biggest telco is actually Telstra. All right, so Telstra basically is one of our customer. In Singapore, we have like Singtel. All right, Thailand we have a few. All right, I don't have the list of customers with me, but we are everywhere. In other words, so long as all these guys basically want to do any kind of system setup, like data center kind of implementation. Okay, so then you will want to be able to see some of our implementation at Cumulus Linux. Okay. All right. So I think I'm speaking a little bit fast, so I'm going to slow down a bit, all right, in case can let you guys hear me properly. So this is what I actually mentioned early on, right? Legacy networking. Okay. So you see, legacy networking basically you can't do any kind of customization. It's kind of like you buy it or you don't buy it. All right. So open data, open model basically means that you have something like what you've seen here, all right, the network OS, then the hardware, and then you can build your apps. Okay, so in other words, using Cumulus Linux, you can also build your apps on top of it if you want. Okay, you can build something on top of it if you want. But you know, for Cisco, Arista, you know, Juniper, all these guys, right, you won't be able to do any kind of customization, right? So if you actually want to buy any kind of apps, right, you have to buy it like from Cisco. Right, there's a Cisco whatever, Cisco Nexus Manager or Cisco ACL Manager, things like that. Okay, but if you adopt the open model, right, open networking model, all right, because we are basically separate, right? Network OS is network OS, all right, hardware is hardware, app is app, so you can actually do your stuff at all these different layers. Okay, so. These are just some of the stuff that you actually see. Right? We have a whole list. Okay, in fact, today if we talk about like RFP, right? When we have RFP, a lot of folks is actually using Cumulus as kind of like a standard. Okay, so from RFP perspective, then you know they will compare. They'd like to compare Cumulus, like for instance, with Cisco or Arista. Okay, like Cisco has STP, does Cumulus have this. All right, Cisco have this, does Cumulus have this. So basically, you can say that most of the time we can match what Cisco, Arista, all these guys has in the data center. Okay, so Cumulus Linux networking operating system. So at the same time, we support, as mentioned, automation. So some of the common automation tool today will be Ansible and Salt. Of course, you have, if you heard of Puppet, you heard of Share. You know, they are also similar. Okay, the de facto is actually Ansible. Okay, so I'm going to skip some of this, some of the stuff here, just to let you guys take a look. So coming from Cumulus point of view, we actually have two products, all right? Okay, so we only sell software, right? So a lot of times it's quite interesting because when we talk to a networking vendor, a lot of times the networking vendor will also take care of your hardware, all that. But really speaking, from Cumulus perspective, we don't really want to call ourselves a hardware vendor or what. We want to call ourselves more like a software guy. All right, and that's why today the software part we are there. So we are the network OS. We are the network OS only. So from our perspective, our product is actually just the Cumulus Linux. On top of the Cumulus Linux, we have another tool, what we call NetQ. NetQ is actually a telemetry. All right, it's a telemetry tool that you can actually use in the operation. Because I think this back to the story I just preached earlier on. All right, imagine, say you have like 10,000 switches. Okay, so 10,000 switches, if you talk about in the olden days, like you have 10,000 switches, it's quite impossible. It's not scalable. All right, but today, 10,000 switches, thousands of switches, all that is not a problem. So that's why probably in the early days, maybe you have like 10, 20, 30, 40, 50 switches, maybe 100 switches, okay? So you say you have some kind of problem. So how do you normally troubleshoot? How do you troubleshoot? Most of the time, you would actually just log in or basically based on your experience, right? Or you have a team of like experts, right? So they probably know how to do it and then maybe like take 3 hours, you know, or maybe like 1 day, 2 days, you know, to just be able, okay, to kind of like troubleshoot it. But with NetQ, right, being a telemetry server, telemetry also means that this guy is going to be able to help you monitor, all right, the status of your switch, okay, the status of your devices, okay, when it's in operation, so that when things go wrong, okay, this telemetry server will be able to straight away pinpoint to you exactly what's the problem. Okay, so I know like maybe a lot of you guys, like if you belong to the old school, you like to do debug this, debug that, right? But just imagine if you have like 1,000 switches, not talk about 1,000 switches, maybe like 100 switches, right? So if 100 switches, when you want to say there's a problem, which one do you know how to debug? I mean, which device you debug? Maybe you say I narrow it down, you know, to the edge or to the core, whatever. But say that you do not know exactly. All right, say the symptoms does not exactly tells you whether it's the core or whether it's the edge, right? Then you have to do what? You probably have to do debug, you know, at all the devices. So by the time you finish all the debug, right, on all the devices, all that, it probably takes what, hours, if not days. So just talk about 100 switches. So imagine you have 1,000 switches. If something goes wrong, and if you were to use the good old method, right, you probably can't actually. You will have a very, very long downtime. In other words, the downtime maybe takes maybe like hours or even days. So that's why in today's environment, this is not acceptable. Okay. So that's why today in environment we talk about scale, meaning you can do rapid provisioning with many switches, many devices very quickly. That's one thing. But at the same time, also manage all these devices when they are in operation and find out the problem within what? Within minutes. All right, within minutes, not within hours. So that's why you have to have some kind of telemetry device. Okay, so a telemetry device coming from Cumulus, right? It's actually NetQ. So normally we kind of bind them, like we call them twins. Okay, so the Cumulus Linux is actually the one that you actually do your implementation. So the NetQ is the one you probably need, right? If you actually want to manage all these switches, all right, when they come into provision, when they come into operation. Okay, so the rest is just some slides on the hardware. all right, vendor. So basically, we don't really touch a lot on the hardware part, okay? Because the hardware part, we leave it to our vendor. So today we have more than 100 certified hardware vendors, but the more common one is Dell, all right, Dell guy, all right. So Dell, the Dell boxes basically run very well with Cumulus. So if you like Dell, all right, you can actually use Dell, all right, as the hardware. Okay, this one I will just go very briefly, right? Okay. The other one is actually Manalox. Okay, so Manalox is kind of a different breed. Okay, as you know, right? Whether today, right, there's two different types of switch exit out there. Okay, one is what we call Broadcom. The other one is what we call Spectrum. So the Broadcom part basically goes to folks like Dell, folks like HP, you know. So Manalox is actually interesting because Manalox, in this case, like, they have their own exit and they call it Spectrum. Okay, so today out in the whole world, entire world, there's only two types of switch exit out there. One is actually the Broadcom exit, all right, where we have like Trident, you know, the Trident, you know, the Tomahawk, you know, Jericho, things like that. Okay, and of course Manalox. Manalox basically have Spectrum 1, Spectrum 2, today Spectrum 3 is now. Okay, so and interestingly, Manalox, this one's maybe we can leave it someday, right? To talk about it. Like someone from Manalox will probably tell you more about this. But normally in Cumulus we call Manalox something like a Ferrari, but it's not an expensive Ferrari. So meaning that in terms of the switch exit that Manalox has, right, it can actually do quite well, better than Broadcom in some cases. Okay. So this Manalox, okay, and of course we have our own turnkey. Because some folks say that, hey, you know, we ask Cumulus, you know, doing a deal with Cumulus means that I have to get the hardware, then I have to get the software, then I have to load the software into the hardware, things like that. So we also have this turnkey where we will sell you the hardware and the software together. All right, so we call these Cumulus Express. Okay. But the switch that we use here for Cumulus Express is actually OEM from a company called EdgeCore. Okay, EdgeCore in fact is actually a company, a subsidiary from a company called Acton. So Acton is a company that basically does a lot of OEM, you know, hardware, switch hardware parts for various vendors out there. So we talk about like Cisco, we talk about Arista, we talk about Juniper. Most of the time, with all those switches, they also got it from this guy called Acton. Acton is a company that's based in Taiwan. Okay, so today they are also one of the largest hardware platform vendor, open hardware platform vendor out there. Okay, so for Cumulus Express, basically we actually use you know, the switches from EdgeCore. Okay, so again, coming from Cumulus, we don't manufacture our own switch, right? Hardware switch. We only do the software part, all right? The Linux part, the OS part. Okay. So this is the one I mentioned, right? Broadcom and Manalox. So there's only two exits out there. Okay, so I won't delve too much on this today, but probably I will just show you guys a data center setup, all that. Then we can go to the we can talk about the campus, all right? Because the main theme today is more on the campus. Okay, this is kind of like what we have been doing. Campus is something that we are actively trying to go in. Okay, I think some of you guys are probably now are from you know, universities, you know, tertiary institution, financial institution, all that. Okay, you probably have like two things also. You probably have data center, but the other part, of course, big core of your implementation will be campus. Okay, so the typical data center evolution, as you've seen here, on the left side, right, is actually what we call legacy. So legacy, you have what we call switches with blades, right? So in other words, it's one big chassis, what we call chassis-based kind of switch. All right, chassis-based means one big box. Inside you have many blades, all that. Okay, but today, if you look at open switches, right, open networking switches out there, all right, or the white box switches is what we call rack-based. All right, that you see on the right. So most of those vendors that you see, like Dell, HP, you know, Lenovo, Mellanox, all these guys that actually implements open networking, they won't be using a blade switch anymore, all right, or chassis-based switch anymore. They'll be using what we call a rack-based switch that's on the right, okay? Because the whole thing, we don't really need to have a chassis-based environment anymore. You know why? Because the whole thing here is it's the architecture that we've seen here, right? Okay, what the architecture here is what we call a cross architecture. This particular architecture is actually by a guy. Cross is actually a name. All right, someone by the name of Charles Cross. Charles Cross came up with this, I think, probably maybe close to 100, not close to maybe 80 years ago, 70 years ago, right? Charles Cross was a last century guy. All right, but when he actually came up with this architecture, it's not really meant for data center. It's more meant for like kind of simple kind of networking, all that, right? But today we call this a spine and leaf, okay? Spine and leaf kind of implementation. You can actually call it, in fact, the spine and leaf was previously adopted. If you really do a lot of WAN work, right? Wide area networking, we call it hub and spoke kind of implementation, okay? But we probably don't like to use the word hub and spoke in data center. It's not very cool. So spine and leaf sounds like, hey, well, this is like something new. And of course, sometimes we call it a cross architecture, okay? Because with something like this, right, on the right side, if any of these switches, either on the top one, right, the top one is the one I call spine, right? The bottom one is what they call the leaves. So anything that is see on the top, right, if any of these spine goes down, as you can see from the redundancy perspective, right, is transparent. In other words, from the leaf perspective, leaf don't really need to worry anything. So in other words, you don't need a chassis base with many blades as a spine. All right, a rack-based switch in this case will do. Okay, and a chassis with many blades will also kind of like increase the latency because the blade is actually itself, right? Each one of the in a chassis base, each blade itself is kind of a module by itself. So from the networking term, we call it a hop. So if you have 3 blades, right, typically it's 3 hops. So in terms of latency, a chassis base not necessarily means it's in terms of performance is more effective than a rack-based kind of implementation. Okay, so this is just for your information. Okay, so this is just some of the stuff. So it's very hard to configure. All right, it's impossible to automate if you are keeping the old one. All right, there's hardware limitation. Then you have to learn a lot of things. All right, every time you come up with new things, all right, you have to learn. So why Cumulus is the solution? Because you have the right architecture, all right, you have the right software, you have the right operation. Right operation as mentioned, right, early on is the telemetry portion, right? You have NetQ, okay? So just some of the basics that you've seen, right? You can see a topology like this. Okay, we'll talk more about this later on in the campus. Okay, but just to show you a simple implementation, a spine and leaf implementation here. Okay, so this is what we call a 3-way. All right, 3-way basically means 2 layer. All right, just one spine, one leaf. There's also what we call 5-way. 5-way basically you can build another layer on top, right, of the spine, what we call a super spine. All right, so the super spine will be the actual spine. Then the spine that you've seen here will become the leaf, and then the leaf will actually in turn be the actually be the lower end, all right, to the spine. Okay, so why this is important? Why I want to show you guys this topology is because later on in the campus, right, when we talk about Cumulus in the campus, we're going to actually adopt the same topology. Okay? As you know, in campus, this is not very possible, or this is not the topology that you probably have, all right, today. Okay, but from Cumulus perspective, when we go into campus, one of the most important things is we want to bring along this data center architecture into the campus environment. Okay, so I'm not going to talk about all this anymore. Just want to show you this architecture. So later on in the next slides, you will be able to see okay, something familiar. But just want to show you guys a quick implementation from implementation perspective, right? The one on the right that you've seen, right, the right column, is actually using Cisco NXOS, right? It's a Nexus, right? The one on the left is actually Cumulus. Okay, so if you compare configuring EVPN, right, so-called data center EVPN or BHP EVPN using Nexus OS, right, versus Cumulus, right? To do that, right, Cumulus basically just requires 11 lines, 11 commands. That's it. Now, if you do it on NX OS, you probably need 92 lines. So just imagine, you have to do this like for 100 switches, all right, or maybe 1,000 switches, okay? And these 11 lines of Linux code, right, like Cumulus Linux code, you can easily automate it. Those 92 lines, right, from the Cisco, right, perspective, is very hard. You probably, when you automate, you probably also need 92 lines. So just imagine 92 lines for one switch, right? So you just multiply it by 100, right? Then it's like 92,000 lines, you know, for 100 switches. Okay, when we do 11 lines for a switch, right? When you multiply by 100, doesn't mean it's 1100. Okay, because most of the stuff that you see, right? You can see that most of the command is the same. Okay, from Cumulus perspective. So you probably need to only change one. You only need to change maybe the loopback address. Maybe just need to change the loopback address and maybe the VLAN ID. That's all. Okay, so that's the beauty of why it's so good to actually use Cumulus or to use actually Linux as a platform, because Linux in a way is very optimized. It's very simple as compared to you know, proprietary net OS. You see, they have to do like so many lines, you know, just to actually complete the same task. Okay. So I'm going to shift to the next slide, next preso here. Okay, so just bear with me, all right, for some time out here. Okay, so this is quite a good poll actually. So, you know, 400G today is out there. Okay, so it's actually supported both by Broadcom and also by Mellanox also. So Mellanox, to support that, is actually based on Spectrum 2, right? Spectrum 2 can already go up to 400 gig. Okay, and Broadcom also, right, so the Trident, right, the Trident 3, the Tomahawk, right, Trident and Tomahawk exit, right, can also go up to 400. So today we can actually support up to 200 gig yet. Okay, we are actually doing testing, because this one is actually you see, from Cumulus perspective, we can support any kind of speed, but we can't actually say we can support it immediately, because these are hardwares. All right, hardwares basically always need to integrate with the software. So we have to run the Cumulus Linux on top of all these hardware platform. Okay, then do some QA tests, all that, right? Then after the QA test, then we make sure that it works, right? Then we can say that we can actually work with this particular, you know, 400 gig box, you know, so on.
Yep.
Okay, so it's interesting. You guys actually, from the poll, right? There's actually some percentage on 400 gig. Okay, that's good actually, because 400 gig is what we are targeting. That's where you probably should build your spine, or what we call your super spine. All right, if you already have so-called spine and leaf card implementation, then with 400 gig, right, you can build another layer, what we call super spine. Then the spine now can become the leaves. All right, then you have 3-layer kind of. So it's become very scalable, very scalable. Also see that there's quite a lot of like 40 gig, right? That's quite common also. Okay, but notice if you use 40 gig, 40 gig is considered as a spine. All right, spine typically is 140. 25 gig is actually more what we call leaves. So if you use 40 gig as a spine, it's kind of hard to become like after 40 gig, right? To actually how do you going to place it? But probably 40 gig, if you actually were to go for a so-called a ramp up, right, in the future, you probably you might want to use it as a leaf net, because 40 gig quite hard to play with, meaning that you can't go too high, and then it can actually step down, but it's only 40 gig. So the next thing we're going to talk about a little bit is actually just campus design. Okay, this is based on the spine and leaf, right, architecture that we talked about earlier. Okay, so we're going to discuss some of the design principles out there. Okay, and then we're going to look at how you can actually segment your design from a campus perspective. Okay, and some of the recommended design. Okay, so what we want to do here from the campus perspective is we are actually doing, we plan ourselves come out like an open networking leader, all right, an open networking leader in data center, okay, in data centers. But from the campus perspective, we try to be a visionary, meaning we want to port what we are doing in the data center, okay, to the campus. So some of the design principle, you probably this is what you have, right? If you talk about, that's why it's a totally different world, okay? And today this world here is pretty dominant by Cisco, all right? Arista maybe, okay? So data center today, not so much, right? Cisco or that. That's why it's a mix, maybe Arista, you know, maybe a little bit Cumulus. But this portion here is the classic, because this is where Cisco starts. This is also where most of the enterprise in the early days, right? You talk about like 20 years ago, early days kind of implementation is always something like that. Okay, you have a core, then you have a distribution, and then you have access. Okay, so and then your layer 2 and layer 3 is very interesting. See, your layer 2 is all the way. So your access layer, right, is typically layer 2. All right, no IP, all right, just VLANs. Okay, only up to the distribution layer, then you have IP, all right? You have routing coming in, layer 3. Okay, and of course the call basically will be very fast. But fast basically in the early days when we talk about fast, it's not 400 gig, probably maybe like 10 gig. All right, a call like a 10 gig switch in the past is considered very fast. Okay, but today, you know, we have 400 gig. Okay. So this slide just show you some of the intro, right? So core is basically just layer 3. Distribution is actually layer 3 and 2. This is what in layman term we call it a demarcation point. All right, a demarcation point between layer 2 and layer 3 kind of implementation. Okay, access layer of course is the one that you connect all your devices. Okay, so access layer, the important thing here is the port density is very important. In the past, we don't have a switch with very high port density. Maybe you only have like 48 port, right? So we have to maybe buy like maybe 10, you know, 20, 30, 48 ports, right? Just to make sure it can actually plug in all the users. Okay, but of course today this access layer has changed also. Guys, in the past, you know that Wi-Fi is not very advanced or that, or it's not very fast. But today with Wi-Fi coming in, like the next generation Wi-Fi coming in, you probably don't need the high port density anymore. Okay, so from the Cumulus perspective here, the translation here, okay, in the modern 3-tier kind of implementation, you can see there's a difference, all right? In the one on the left side, you see there's a layer 3, layer 2 kind of demarcation point at the distribution layer. Okay, so for Cumulus perspective, we want to try to push this whole thing to layer 3 and layer 2. Right? You still keep your layer 3 and layer 2, but in this case, you can push this all the way to where? To your access. Okay, because in the past, access, as I mentioned, is they are just dumb switches. All right, meaning they can only just do VLANs or that, nothing more. Okay, but from Cumulus perspective, from a campus, our campus perspective will be to transform your distribution in this case to a spine, all right, then access in this case to the leaves, all right. So in that case, then we can do layer 3 from the access layer onwards, all right, and also still keep the layer 2 devices. Okay, the nice thing here is because you see in the first case, if you actually propagate, if you keep your layer 2 all the way until distribution layer, I think one of the common problem, the common nightmare that we have today, okay, in a legacy environment, I think you guys know, right? Spanning tree, right? This one is a pain, because when you do spanning tree, you know, spanning tree basically will kind of like, if you're not careful, right, there's this thing what we call loops, right? Spanning tree loops. If you have loops, then you have problems. right? Because when layer 2, when they have loops, it means that any kind of broadcast will continually be actually loop round and round. All right, it's kind of like a snowball effect. So it goes on and on until what? Until your network hang, then your user complain that, hey, now everything is very slow, or your user complain that I can't access anything anymore. Okay, so the nice thing here is if you push everything, your layer 2 or your layer 3 further down, all right, to the access, and keep the layer 2 really at the endpoint, then you can actually solve a lot of spanning tree issues. All right, you have smaller spanning trees. Okay, and then you have reduced dependency on folks like MLAG. MLAG, I mean, from Cisco perspective, I think you guys know there's this thing called what we call VPC, right? A virtual port channel, right, protocol. Okay, so I think Arista also uses the term MLAG. We support MLAG too. All right, so from Cumulus we support MLAG, but MLAG has lots of issues also. Okay. So this is a nice scenario that we want to implement, right, in the design. So in modern design, in a 3-layer design, you still keep the 3-layer design, but the distribution layer and access layer from Cumulus perspective will be very much like a spine and leaf kind of implementation. Okay, so from the aggregation access portion, this is actually the most well-known segment. This is where the user and the devices, so everything except the core tree. So this is the aggregation and access portion. So this is one point that you can work with. Okay, so meaning that coming from Cumulus, what we're trying to do here is that if you still have a 3-layer, or a core, a distribution, an access layer. Okay, a distribution is also called aggregation layer, depending how you call it. Okay, you can actually try to change this design, okay, to a spine and leaf kind of implementation. In other words, using the spine concept for the aggregation, using the leaf concept for the access. Okay, so that's how we think we can actually come into the campus environment, right, in this manner. Okay, so we're not going to actually do the good old aggregation and access kind of implementation, right? But we're not going to really take away this from you guys. Right? We're going to tell you, hey, change everything. No, okay. We can come in as something like this, right? This 2-layer here, right? Aggregation access, all right? Change it to spine and leaf. Okay. So other than that, there's also a service layer. Okay, the services out there. Okay, so with the aggregation and access point of view, right? Because this is quite popular. This particular diagram here is quite common in the data center. Because in the data center, the aggregation will be the spine, the access will be the leaves. Okay, so how do they actually then go out? Or how do they actually access services? Okay, in a campus environment, in aggregation, right? In the aggregation layer, normally we have another pair of switch, what we call service aggregation switch. All right. So under the service aggregation switch, this is where you can connect your, load balancer, your voice over IP, your telephony, servers, firewalls, Wi-Fi controllers, all that. Okay. So this part here, when you actually make the decision to actually change, right? Instead of having another pair of Arista, another pair of Cisco, you probably can also choose Cumulus in this case, right? Because we can actually work the same here. All right. So of course, then in data centers, like server rooms, all that. All right. Then you can see, you probably have you can actually have leaves. Okay. So from the distribution portion here, you can see. Okay. At the distribution access portion, we can actually build, in this case, as I mentioned, spine and leaf. Okay, but you probably have other servers at a server room and other places there. All right, so you can actually from the spine, okay, you can actually connect from the spine. Long distance. I mean, campus basically means that it's probably maybe within 5 kilometers. All right, So you can actually kind of have a direct homing, right? Cable homing to respective leaves, all right? Respective leaves at your server room. Right? I'm not sure whether you can see this properly, but let me see whether I can highlight it. No, sorry. Okay, so it doesn't matter. Anyway, let's look at the recommended design. So in a small kind of setup that you have, you can actually implement, all right, if you want to actually use Cumulus, how do you actually start using Cumulus, right? Small typically can be pretty much what we call greenfield, right? So greenfield basically maybe it's only you know, a small startup, all that. Okay, so you can actually use a Cumulus, a single Cumulus, all right, on the left side, moving towards you know, a pair, all right, if you need redundancy, all that, and of course then using a pair, then you can actually just connect it directly to the edge, all right, to a router to actually go out to the internet, all that. So this is actually very neat, all right, small and sharp. And then you probably have a single site, okay, a single site kind of implementation. So a single site implementation, if this is greenfield, then it will be good to actually again make use of a two-tier, all right, two-tier or three-way, what we call a three-way spine and leaf kind of architecture. So you build your distribution layer, okay, you build a distribution layer, and this distribution layer is kind of like the spine, and the access layer basically is where you have the leaves, okay, and from the distribution layer you basically connect it out to the WAN to go out to the internet. Okay, so the one on the left and the right is kind of the same, except the one probably on the right side you have more spine, okay, spine switches. See, the whole thing here is when you actually use a spine and leaf kind of architecture, so spine is the one that provides you the bandwidth. So you want things to be fast, right? You have more spine, okay? If you want to save cost, right, you can have less spine. The leaves, right, is the one, right? Leaves in this case, the access is the one that provides a port density. Okay, so if you say run out of like user ports, all that, you just add in more leaves. Okay, the consequences is if you only have like two spine and many leaves, means that the two spine will kind of like what we call oversubscribe. Okay, so if everyone actually use all the ports on all the access, right, then the spine itself will be oversubscribed. Okay, the best performance means that you have the same number of spine versus the same number of leaves. Okay, or the same kind of speed that you have, right, on the spine. Okay, that to be able to support all the leaves. Okay, that will be the best, but that is also a more costly solution. Okay, but a single site you can actually do something like this. Okay, and this is where your VPN can come in, because if you are using the data center concept, right, from Cumulus, even though this is a campus, you can actually build your VPN, okay, your EVPN and VXLAN very easily. Okay, so you can actually do all your tunneling within this distribution and access layer. Okay, within the distribution and access layer, you can actually do all your VXLAN tunneling. Okay, and of course, then you can actually extend your, VXLAN basically. Using VXLAN, you can actually extend your VLAN, your layer 2 adjacency, okay, between two switches, all right, or two different server clusters. Okay, so this is the one that you have going out the core. Probably this particular setup is you probably have need to go out in this case to the internet. Okay, so you can actually set up another pair. Okay, you can call it a border access if you want. Okay, in data center we call this border leaves. All right, in campus you can call it border access. So border access basically goes out then to the internet. Okay, this one basically shows you multiple layer. Okay, multiple distribution. So you can see multiple sites. Okay, so at the different sites you can actually have variations. Okay, have variations like in this case, right, the one on the left side you can see, right, it's actually pretty much a spine and leaf implementation. Okay, you have your spine and leaf right on the left side. And then on the bottom side, there's also spine and leaf, right? Of course, in campus, we call it distribution and access, right? On the bottom, then you have all your core, okay? You have all your core, and then you have two on the right side, right? You can actually have two border access to go out to the WAN edge. Okay, and of course, if you are using this particular architecture, then you could actually do EVPN and VXLAN, right? No problem, right? So because if you look at EVPN and VXLAN, you can actually, do VXLAN all the way. So you can from the leaves on the left, right? You can actually do your VXLAN tunneling, okay, to the distribution layer on the bottom part. Right? You can actually do VXLAN tunneling all the way to the border, all right, to the border access also, all right, on the top right. Okay, so for large building, multi-site kind of implementation, you see the difference between this and the previous one is that there's still layer 2, all right. You see the dotted line, right? The dotted purple line, all right, in dotted line. Okay, that's the demarcation point. Okay, so in a large building, okay, you typically take away all your no more MLAN. Okay, you do all the way layer 3. Okay, so you could actually do everything layer 3. In other words, all the way to your host. Okay, this might not be a very feasible solution to many of you. Probably you might say that, hey, some of my hosts is very dumb, right? You can only do, you can't do routing, you can't support layer 3, all right? So that's fine, but this is in fact the ideal one. So ideally, using this approach, right, eventually there shouldn't be a layer 2 and layer 3 kind of demarcation, okay? Everything should be all layer 3, because if everything is layer 3, you don't have to worry about spanning tree anymore, okay? You don't have to use MLAN, because MLAN is layer 2, right? Okay, so if you use layer 3, then you want to do load balancing, you can use what? You can use ECMP, right? Equal cost multipath, all right, load balance. So because the routing protocol, they can support that. Okay. So the other interesting thing here is, again, this is for your information. I'm not sure whether you can see all these, or you understand all these. There's this concept what we call VRF. I'm not sure whether you guys heard of VRF before. Okay, but VRF is predominantly in the early days. It's kind of a concept by Cisco, Juniper, all that, right, for service provider kind of implementation. Okay, but this VRF, ever since Cumulus come into play, right? We come into play, we do all the development work, all that. We actually make it work, right, on Linux. So in other words, today VRF is actually supported also on Linux, Cumulus Linux, okay, or FR, free range routing line, free range routing daemon running on Linux, okay. So you could actually use VRF concept together in the campus environment. Okay, maybe you already use this, because if you are using a Cisco box, if you are in a campus environment, you probably also has a VRF kind of implementation. The nice thing about VRF is, it's very a quick intro about what VRF is. Normally we have one single routing table, all right? So we are not able to, in this case, support, overlapping IP addresses, for instance. So in this example, maybe you see I have a blue, right, VRF data, and then a red VRF voice.
Okay, so without VRF means that data and voice will actually be on the same routing table. Okay, then it's very difficult in this case to do what we call isolation, to do layer 3 VPN, things like that. So with VRF basically means that you can actually segregate the traffic in this case into two segments. All right, the VRF data and the VRF voice. They can call it VRF basically means that these two streams of data can coexist, right, on the same switch, same router, whatever. But in this case, you can overlap. For instance, my VRF data, I say that I want to have a subnet 10, right, 10.10.10.10.10, whatever. My VRF voice, I also want it to be what, same subnet in this case. So using VRF, this is possible because they won't actually overlap at all. Okay, because VRF basically uses what we call there's a tag what we call RD, all right, a route distinguisher. So a route distinguisher is a 64-bit number, all right, a 64-bit kind of prefix. So if you have an IPv4, all right, you actually put a VRF data. The VRF data will actually add what we call a 64-bit, right, prefix in this case to your IPv4. So in other words, your IPv4 now becomes what, 96-bit prefix. Okay, so even in your 32-bit, right, IPv4 prefix is the same because the VRF, the route distinguisher ID is different. All right, doesn't matter. Okay, that's how VRF works in a nutshell. Okay, but I'm not going to delve too much on that because VRF can be actually quite a topic by itself. Okay, but just to show you that you could actually use this concept in a large building, all right, make use of VRF in this case to help you to do all the segregation because not everything is actually layer 3. Okay, so just some gaps to cover up here, some of the frequent questions here. So why then you want to use Cumulus, or why do you want to do open networking for campus? All right, for campus-based kind of implementation. So the pro here is you have a single management point, you have redundancy, because now you adopt the whole thing is also the design. Okay, it's also the design because now that you adopt the spine and leaf kind of design, you can actually pay as you go. Okay, I think this is very important because ultimately, end of the day, any kind of implementation, especially during these times, I mean, the budget is very important. Okay, the dollars and cents is very important. So you wouldn't want to buy something more or something that you say that, hey, you won't actually last you very long. Right? You only want to buy what you need, and basically want to keep your cash flow. So with a spine and leaf kind of implementation, you could actually just add in more leaves when you need the port density. You can add in more spine when you need the bandwidth. Okay, of course, a lot of times when you talk about cons, there's also software complexity on it. All right, but of course, this particular slide here is telling you about stacking. Okay, so that's why if you look at our implementation, we don't actually implement stacking at all because with the spine and leaf, you don't need to do stacking. Okay, because stacking is actually an old concept, and stacking can't give you very high speed. Okay, stacking can't give you very high speed. Okay, you probably can't stack like 400 gig switches all together and say that, hey, eventually you get like I stack to 400 gig, I get 800 gig kind of performance. All right, that's not what stacking can support. So the other question is, do you really need stacking all that? Okay, so is it a problem, more of a problem? I think if you were in the olden days, when you do stacking, I think there's quite a lot of issues. Okay, there's quite a lot of issues on it. You need cables, all that. So that's on stacking. The other one is actually on chassis. Remember, chassis base. Okay, chassis base, of course, the people like Cisco are starting to preach like system redundancy, high port density, all that. But if you look at the cons, right, it's a very high cost. Okay, because you have to buy all the blades. Okay, right? I mean, in a blade-based environment, you probably need to buy 2 blades, two supervisor engine. Okay, but do you know that even if the whole switch I mean, although the switch itself has 2 power supply, right? But if let's say the 2 power supply to that blade switch is gone, right? So even you have 2 supervisor module, right, in the same blade switch is also gone. But if you actually use a Cumulus way, right, or the spine and leaf, it doesn't really matter because the whole switch can be gone. But because you have multiple spine, right, you still have the redundancy. Okay, and the cost is in fact cheaper than a this kind of implementation. Okay. Centralized configuration management. So if you talk about centralized configuration management, yes, right, NetQ, although it's a telemetry, you can also use NetQ to actually do some kind of config management, some basic config management. So today we're actually moving towards, like, for Cumulus, our NetQ evolved from version 1 now to version 3. So we have NetQ version 3 is coming out soon. Okay, so we have some configuration management stuff on there, right? Besides doing the monitoring portion. Okay, so that's what I have for you guys, right, today in a very brief nutshell, just to show you guys, just to sum up, right, the takeaway here, to give you guys a brief overview of what open networking is, okay, how Cumulus comes in, all right, how Cumulus Linux fit in to an open networking environment, how Cumulus basically can work with multiple hardware vendors, okay, to actually get Cumulus loaded on the platform of your preferred, of your preference, okay, and then how we actually do the deployment in terms of design, okay, the spine and leaf kind of architecture, how to take this spine and leaf architecture in this case and put it in a campus environment, all right, to make it work as it is, okay, and to make it scale as it is, okay, and of course we also talk a little bit about NetQ, all right, how we can actually use NetQ after deployment phase, after implementation phase, to use NetQ in this case to monitor, all right, to perform the operation work for you. Okay. In fact, we do actually have a case where, for instance, Verizon, they have about like 2,000 Cumulus switches, all right, but in their environment, they only have 2 engineers, all right, 2 engineers managing it. So you can see, in the past, if you have 2,000 switches, I don't think you will only have 2 engineers. You probably maybe have 20 or maybe 50. So, but this is possible if you are using open networking, using Cumulus Linux, because Cumulus Linux basically is very simplified. A lot of times you do automation, and on top of that, if you were to use NetQ, right, for the operation perspective, you can actually troubleshoot it very quickly. Okay, so in fact, with such implementation, you could actually have, you do not need a lot of human resources, all right, today, and especially in today's environment with the COVID-19, all that, right? There's no one out there to actually help you to do the troubleshooting. Just imagine if now you have, in this situation where you are in a lockdown, right? You're in a lockdown, you can't deploy manpower. Even if you want to do RMA, right, you might or might not actually make it to your site. So, but say it's not a hardware problem, maybe you need to do some troubleshooting on it. A lot of times we say we need someone down at the site on it, isn't it? But today, you see, with this environment, you can see how useful, how all this concept fits in nicely. Because if you already have a very robust architecture with central management, all that, right? With automation, when you have a problem, the first thing you need to do is remotely, from remotely go into your telemetry server, see what's the problem. Okay, the telemetry server tells you what's the problem, and if your devices itself can do automation very quickly, then you can just run a script, run a simple script to fix it. Probably this whole thing will actually just solve within like maybe 5 minutes. 5 minutes you can fix an issue that probably maybe in modern day, in the early days, right, before all these happen, you probably maybe need to deploy 5 engineers down to site, then they cut their heads, spend there maybe 10 overnight, to just fix the problem. Okay, so in other words, this is as mentioned here, we're actually positioning ourselves as a game changer, and especially in this environment today, you probably do not really have a lot of choice. In other words, you don't really have a lot of resources for you to do it. So a lot of things you have to rely on automation. All right, automation to work for you, or you have to rely on systems to work for you. So your system, your automation, all these have to have very reliable architecture. All right, have to have a very robust kind of software. So this is where Cumulus Linux basically fits in, NetQ fits in. Okay, so that's what I have for you guys today. Thank you.
Okay. Thank you, Eddie. So we will move to Q&A part.
Yep.
ทุกท่านท่านใดมีคำถามเพิ่มเติมอยากจะสอบถามคุณเอ็ดดี้หรือว่าทีมงานไหมครับเกี่ยวกับ Cumulus นะครับก็คิดว่าทุกท่านคงได้ทราบคร่าวๆเกี่ยวกับ Cumulus สำหรับวันนี้นะครับอย่างที่คุณเอ็ดดี้ได้พูดไปนะครับก็ยิ่งในช่วงโควิดแบบนี้นะครับการทำงานหลายๆอย่างก็จะมีการเปลี่ยนแปลงไปในรูปแบบของรีโมทมากขึ้นเพราะฉะนั้นในเรื่องของ automation ก็ตามหรือว่า monitoring ที่มีประสิทธิภาพก็ตามก็จะเข้ามาช่วยตอบโจทย์การทำงานในยุคปัจจุบันแล้วก็สภาพแบบนี้ต่อจากนี้นะครับเห็นหลายๆท่านมีส่งคำถามมาพอสมควรนะครับเราจะหยิบยกคำถามที่น่าสนใจขึ้นมาตอบเพื่อเป็นประโยชน์นะครับมีคุณสามพานสอบถามมาว่าจำเป็นหรือไม่ครับที่ Leaf กับ Spine จะต้องเชื่อมต่อกันแบบ Full Mesh ทั้งหมดนะครับมีทีมงานท่านใดตอบได้ไหมครับ
สวัสดีครับสวัสดีครับ
ครับสวัสดีครับตอบได้เลยครับ
ครับผมก็ถ้าตามหลักแล้วนะครับก็ควรจะต่อเป็น Full Mesh นะครับเนื่องจากตัว Datacenter เนี่ยจะมีการทำงานตลอดเวลานะครับการทำ Full Mesh เนี่ยจะทำให้เรามีตัวของเส้นทางแบ็กอัพนะครับเพื่อป้องกันว่าในกรณีที่อุปกรณ์เกิดมีปัญหานะครับในการส่งข้อมูลเนี่ยเรายังจะมีตัวของฮาร์ดแวร์ตัวอื่นที่ทำ Full Mesh ไว้เนี่ยในการส่งข้อมูลนะครับ
ก็แสดงว่าไม่เชิงบังคับใช่ไหมครับว่าจะต้องเป็น Full Mesh ใช่ไหมครับ
ใช่ครับแต่ว่ามันถือว่าเป็นข้อแนะนำอยู่แล้วครับเนื่องจากถ้าเรามองกลับไปที่ในการดีไซน์ Database หรือว่า Data Center ตั้งแต่ยุคเดิมเลยเนี่ยก็จะเห็นว่ามันต่อเป็น Full Mesh มาตั้งแต่แรกแล้วครับ
โอเคขอบคุณครับคุณหมูครับก็คุณหมูจะเป็น Network Engineer นะครับ EasyNetwork นอกจากนี้ยังมีคุณวาริศถามมาเกี่ยวกับเรื่องของ Management ของ Cumulus อันนี้เป็น Command Line หรือว่าเป็นลักษณะของ GUI ครับ
ก็จริงๆแล้วตัว Cumulus Linux เนี่ยจะเป็นเบส Command Line นะครับผมแต่โดยรวมแล้วก็ถามว่า syntax เหมือนกับแบรนด์อื่นๆหรือไม่จริงๆก็ไม่เหมือนครับเพราะว่า OS เขาเขียนคำสั่งมาเฉพาะให้ทำงานง่ายขึ้นถ้าทุกท่านเห็นคำสั่งไอ้พวกEVPN นะครับในการเปรียบเทียบตัว Cumulus Linux เองเขาย่อคำสั่งมาเหลือแค่11บรรทัดต่างจากตัว Command Line ทั่วไปที่เราใช้งานกันก็คือ90กว่าบรรทัดมันทำให้รูปแบบการทำงานเนี่ยค่อนข้างจะง่ายขึ้นแต่ syntax ในการเขียนเองก็ต้องมีความรู้ในระดับหนึ่งครับที่จะเขียนย่อลงมาเป็น11บรรทัดได้ครับผม
ก็จะได้ในเรื่องของประหยัดทั้งเวลาแล้วก็ได้ประสิทธิภาพคงเดิมนะครับด้วยการทำงานที่กระชับขึ้นนะครับแล้วอย่างตัว Command Line นี่เป็นคนละแบบกับอย่าง Cisco ใช่ไหมครับ
ใช่ครับผมถูกต้องครับเพราะว่าตัวCumulus Linux เองเป็นเบสเฉพาะของเขาครับ เป็นคำสั่งแยกจาก Cisco โดยตรงครับแต่โดยรวมแล้วถ้าเราต้องการคอนฟิกตัวสวิตช์ที่เป็นแบรนด์ต่างๆอยู่แล้วเราก็สามารถเข้าใช้คอมมานด์ CLI เฉพาะได้เลยครับไม่จำเป็นต้องใช้คำสั่งของCumulus Linux ก็ได้ครับแต่ก็จะยาวเช่นกัน
โอเคขอบคุณคุณท็อปนะครับ Network
ครับผมขอบคุณครับ
ครับก็ขอบคุณคำถามจากทั้งคุณสามพันแล้วก็คุณวริศด้วยนะครับมีคุณสงกรานต์ถามมาเกี่ยวกับ Cumulus VX นี่คืออยากทราบเรื่องอะไรนะครับขอโทษทีครับสำหรับเรื่อง VX เดี๋ยวผมขออนุญาตให้คุณเอ็ดดี้ช่วยแนะนำอีกสักรอบนะครับผม Sorry Eddie could you explain more about VX
Okay.
Thank you.
Okay, VX is interesting. You see, VX is actually one of our simulation platform. So I didn't really cover that much because I think in my slide I actually have shown some of the VX. That's actually VX. See, one thing in Cumulus is all our releases, in other words, all the software features that you have, all that, right, can actually be simulated, all right? And we actually release this VX. It's actually what we call a virtual appliance, okay? A virtual Cumulus Linux appliance. So this virtual Cumulus Linux appliance, you can actually use it to do your testing. In other words, meaning that you don't really need to procure, like say, for now, if you say you just want to test, right? Test out like maybe spine and leaf kind of architecture. All right, say I want to have like 3 spine, you know, or 4 leaves, something like that. So you can actually use this VX, right? VX to actually simulate it for you. So VX doesn't tie ourselves to, because if you actually use hardware, because some features may only be able to support on Broadcom boxes. All right, some maybe only on Manalog boxes. So that's why if you use VX, basically it doesn't tie to any particular box. So any feature that we have, you can use it. So like for instance, now we have the new release, right? Cumulus Linux, we have a new small release 4.1. So for VX, you will see a VX 4.1 also. So if you want to test out the latest version, right, that we have, you can actually download it also. So the VX is free. Okay, you can actually download it from the Cumulus portal. So what you need is basically just to create an account. All right, so when you create that account, then you can actually download, all right, the VX and do this. Okay, so the VX itself basically can run on different types of hypervisor. For instance, if you use KVM, right? You know KVM, okay? The QCOW2 extension, right? So if you use KVM hypervisor, you can actually download the KVM one. If you use VMware, right? You can actually use download the VMware version. We also support VirtualBox, right? Oracle VirtualBox if you use that version. Okay, for me, basically, I myself use the VirtualBox version and also the KVM. Okay, if you guys are fans of GNS3, I'm not sure you know GNS3, but if you were to use GNS3, right? You could, because GNS3 you actually use QEMU, right? QEMU. In other words, your KVM, right? Your QCOW emulation. So you can actually use GNS3 in this case with QCOW, right? The QCOW2 extension to run the VX. So you have a lot of options depending what you want to do, but basically you can actually simulate it exactly like what you do for folks like, I mean, for iStar, I think you have a VEOX, like Cisco, they have that some of their, you know, virtual appliances or that. So it's exactly the same as that.
เดี๋ยวยังไงให้ทีมงานลองสรุปคร่าวๆให้ฟังครับเป็นภาษาไทยเผื่อบางท่านที่ยังไม่เข้าใจนะครับเชิญได้เลยครับ
โอเคครับสักครู่นะครับโอเคเห็นพี่สงกรานต์ใช่ไหมครับถามมาจริงๆแล้วตัวCumulus VX เราสามารถรันในเวอร์ชวลต่างๆตามที่ Eddie แนะนำก็ได้ครับจริงๆตัว KVM ก็เหมาะที่จะได้ทำการจำลองขึ้นมา แต่ตัวแรมและ CPU ของเครื่องนั้นเองแนะนำก็ต้องเยอะมาในระดับหนึ่งแต่ทางผมเองแนะนำเป็นพวก GNS3 นะครับหรือไม่ก็เป็น EVE-NG ครับคือตัว EVE-NG เองสามารถรองรับตัว Cumulus ได้ครับสมมติในกรณีเราแอดโหลดขึ้นมาตัวลิสต์ของเขาเนี่ยครับเขาจะมี Cumulus มาให้เรียบร้อยแต่เราต้องโหลดตัวเทมเพลตตัว image มาใส่อีกรอบหนึ่งซึ่งผมเองก็มีการจำลองเล่นในนี้เช่นกันครับทีมงานเราทุกคนก็คือจำลองอยู่ใน EVE-NG ทั้งนั้นเลยถ้าเป็นแนะนำนะครับผมแนะนำเป็น EVE-NG ได้ครับแต่ถ้ามีทรัพยากรที่เพียงพออย่างเช่นแรมที่ถือว่ามากในระดับ16 จิกขึ้นไปอะไรแบบนี้ครับ CPU มากกว่า4 คอแนะนำเป็น8 คอขึ้นไปถ้ามีได้ก็แนะนำเป็นพวกเวอร์ชวลต่างๆสามารถจำลองขึ้นมาได้ครับประมาณนี้ครับผม
ก็ขอบคุณทุกท่านอีกครั้งหนึ่งนะครับสำหรับการติดตามแล้วก็เข้าร่วมงานสัมมนาตลอดเมื่อวานแล้วก็วันนี้นะครับแล้วก็ขอบคุณคุณเอ็ดดี้ครับที่ช่วยมาแชร์ความรู้จาก Cumulus นะครับ so thank you very much Eddie